Hello friends, myself Vinod Kenny. I am signing in for you and have brought a fault no picture in LG LED TV. How we can fix this fault? It is all about that. Now I will describe everything, every facts about how this fault can be fixed. Before that, I would say that does not have subscribed my channel. Please subscribe that channel so that you get connected with me forever. How you can subscribe? You can go to the red button below my video segment. You can just press it and subscribe my channel and you get connected with me. Now I will tell you about this video. First time I am giving this technical guide in English so that all the people who are living abroad in foreign countries who does not know Hindi can understand what I am willing to say. Okay, so let's start the video with how we can fix this fault. This is a LG LED TV with no picture and backlight is okay, sound is okay. So we can go ahead with this fault, how we can detect the fault. Okay, so first we have to do one thing, because it is a no picture fault. No picture means what? Backlight is okay, that means light function is okay, and if light is coming, backlight is coming, that means tick on is okay, tick on voltage is present, and tick on MOSFET is switching that 12 volt to panel, and it is giving a panel supply. Okay, so we understand by this fault that backlight is okay means we have a panel supply here. Okay, so how we can fix this? We go ahead with this fault. First of all, what we have to do in this, let's understand that. Basically, I have done one thing, that I have disconnected its original motherboard from motherboard connector, LVDS connector from this panel, and connected my universal board, and had programmed this universal board with the resolution of 1366 multiplied by 768. First of all, I will explain that what is this resolution all about. Just come here. I will show you how resolution is created in a TV. Okay, so this is a basic television structure, right? So this is a horizontal area and this is a vertical area. So vertical area presents that the pixels from top to bottom. Pixels means the dots, which one dot is one pixel, and 1920 dots means 1920 multiplied by 30 colors means 1920 multiplied by 3 colors, which is RGB. Okay, so we have to calculate like this. It have a pixels in this area is 1920 multiplied by 3, and in this area pixels are 1080. Okay, this is all about this panel, but in this panel it has a pixel of 1366 from left to right. That means horizontal pixels are 1366 multiplied by 3. That means basic 3 colors, primary colors, red, green and blue. Okay, which is aligned RGB like this in whole area, printed in whole area, top to bottom also. All R in one line, all G are in one line, and all B are in one line. So red pixels in vertical area are 768, and RGB pixels in horizontal areas are 1366. Okay, so this panel is 1366 multiplied by 768, and I have given this board with that pixels only. I have just corrected that resolution matches with this panel. Okay, so let's go ahead. Already this board is programmed with 1366 multiplied by 768 resolution, so it has to give that output to run this TV. But what happens, we will see in the later video, that when I start this TV, what happens? Just see one thing. Okay, you get a spark here, right? So first of all, whenever there is a TV with you, just open the front of this area so that you can visualize all the area, and you can inspect all the fault which can be physically seen or not. If not seen, you have to check the voltages. Okay, so first of all, we will start with a voltage, how this fault can be corrected. So first we have to this video is all about how we can fix this. And one more thing, whenever you start with any TV, just keep a universal board handy with you, and make that board with software like that panel resolution matches with this board. So this board is programmed with 1366 multiplied by 768 pixels, so that it gives the output LVDS output of 1366 horizontal pixels and 768 vertical pixels, and it matches with this panel, right? This panel is all about 1366 768. And one more thing, you have to give a panel voltage as per that panel supplies voltage. You have to give 12 volt for this panel, because this panel is working on 12 volt. So we will make all the things clear for you. First of all, whenever you start the TV, just make this in ready, multimeter in range, DC range, voltage DC range, and you just connect the power supply and check the voltages. First of all, you have to check this voltage. So this 12 volt should be present. You just bring that and focus on that display of meter. It is showing 11.83, that means it is okay. On the other hand, we have to check the voltage. It is okay, that means these two sides of that fuse is getting a voltage, that means fuse is okay. And one more thing, we have to come here, and it is an input for this TV, so we have to check this voltage here also. So you can see that this voltage is not present here, but 3.3 is working, that means this IC is working, because this boost up coil is getting a voltage from this IC only, and 3.3 is producing by this IC. That means this IC is okay, and this voltage coming out from this IC, that means its boost of voltage is working. Now check all the parameters like VAA supply, which means it should get 16 volt, but you can see in display that I am not getting even a 1 volt. That means this voltage is not coming out from this IC, right? This IC has the work to get this voltage out, but this IC is not giving this voltage. That means this IC is in protection mode, or this IC is not producing this voltage. So how we can find out that this IC is defective or not? First of all, whenever you start the supply, you just connect this multimeter probe on that area, output panel voltage, and just check this first supply, because this is the first supply, boost up supply, which is coming out from this IC. It is around 16 volt. After this, all that boost up voltages like VGH, VGL will come out. VGH means voltage gate high, that means it has to get about 27 volt, and VGL means voltage gate low, it has to get around -5 to -8 volts on these test points. So after this voltage would be coming out. So first of all, whenever you connect the power source, you just get ready with this area, so that can you mind if you plug in this cord into it while I am holding that voltage, and you just keep an eye and camera on this multimeter. Can you see that it had got around 13 volt? After getting the 13 volt, this value is 0 volt. That means this panel was getting the voltages. That means this IC was producing voltage, but due to some problem it gone into protection mode, and this voltage was not coming out from this IC any further. So we'll check that what will be the circumstances for that, why this voltage is not coming out from this IC. Okay, so let's check that thing. After that thing, again you have to see this voltage here also. This voltage is still present. That means T-con on is okay, and this T-con on MOSFET is okay, and that 12 volt is coming out that from that power supply, and from through that MOSFET source and drain, and it is coming here. That means this circuit is okay after starting the TV, but this voltage is not present. That means this IC is not working anymore. So we will check that why this IC is not working. First we will see that which is the gate area from here, right? Gate area means one of the side is a gate area for this panel. Gate area means it is a working area for a gate signals. Gate signals means what? VGH, VGL goes through this area only. If this voltage is not making, this IC is not making that voltage at all, after switching on for a second also it is not giving this voltage, that means this is not working. If this voltage comes out from this IC and just goes off in 1 second, that means this IC was producing the voltage. Due to some reason that voltage was not coming out after 1 second, due to some reason. So we will check about that reasons. First of all, we have to know about the gate signals, from where this gate signal is supplied. So you can see that the right area, okay, right area means this is a gate signals signal area. So we have to just remove this cover from here. So I am removing both the sides of this panel, means left and right, and let you know that from where this gate signal is running. Before that, please disconnect the power supply from the television, so that there is no problem in your panel while short circuiting any area. So you can see that both areas, okay, both area has only one side of working gate area. You can see here, right, it is on the right side of this TV. Okay, so these are gate coughs which gets a VGH and VGL supply for running the pixels, okay, from left to right. Means this gives a one line. If I talk about one line, it gives a VGH for 1 second in that one line, and this pixels running in that area gets the picturization. So it is how that works. So we'll see that either this cough is defective or some other thing. Before that, we have to just physically check the cough area. So we'll check this cough also, every cough, but I just see that if the gate area is this one, so this cough is more vulnerable for the defect. Okay, so we'll check this cough. So how you can see that, and you just make this cough of the back area, and you can see this mark. It is a burn mark over here. So this is responsible for that spark, and that spark is making this IC after getting that voltage, it is disconnected and it doesn't give any output anymore. After that spark gets into contact with this IC, it gets a feedback that it has to close down all the voltages, so that it is a panel safety. It is for panel safety. If this voltage will not go off, then this cough will blow off, and this ITO area over here where this cough is connected on this panel, that area burns off, so that we cannot even bond this cough here, right? If this area is burned, that means we are not able to connect this line with this panel, and this panel cannot connect with this cough if this ITO lines burns itself. So we have to just keep in mind that this protection is for that cough safety and ITO safety and panel safety. Okay, so that's why it is designed like that. If any spark gets in contact with this IC, this IC will just remove all the voltages from it. After that protection get in contact with this IC, and that feedback is received by this IC, it will not give any more boost up voltages. Only 3.3 volt will only work, only the output 3.3, that means step down voltage will be there, but all step up voltage, boost up voltage will be removed from this IC, so that there is no further damage for this panel. So I will remove this cough and show you that this IC gives the output or not. Let's start removing this cough. First we have to remove it from this area, that means PCB area. Remove this cough from PCB area first, then remove it from panel area. So you have to keep this in temperature like 316 degrees centigrade, and just do like this, so that it gets a heat in all area, and then go with just lifting up from all areas one by one, so that this cough comes out of the source PCB. Okay, then drop down the temperature to around 205 to 210 degrees centigrade for panel area, glass area. This much is okay. Now do one more thing, just take the toothpick and remove all these things. Before removing the cough, so that while bonding, during bonding process, you can just remove the ACF from this area, from this ITO. So I have removed this cough from this panel, so that I can check the further voltages, about the voltages, how it should be there, and I will show you from where this burn is. So this burn is from this area. The cough number for this is 8157- CC 501. Now I'll see that what happens to these voltages. So I keep one, means you just plug it in while I hold that output voltage is 1 minute. Yeah, now. So you can see that this voltage is there. When I start it, you just see that this voltage is present all the time. it is not going off after switching on. And VGH supply, I was telling about that it is a picture on supply, and this is a picture off supply, minus 6.11, and VGH is 29.89, it is a picture on supply. So I am getting all the voltages which panel should produce, from 3.3 to HVAA it is around 6.72, and VGL it is around minus 6, and VGH, which is picture on supply, by this signal only you see the picture coming out in a moving imaging direction. And one more thing, we get a voltage for COF also, it is around 15 volt. So this all voltages are present, that means this panel is ready to work. Only the thing has to be done is we have to fix that COF with a bonding machine, new COF in this area, so that this panel works again. I will try to show you the bonding process of this panel while I receive this COF and I start a bonding process in a next video. So dear friends, I am signing off for now, and just making sure that next video also comes to you very soon, and I will just show you this panel working after bonding process, bonding the new COF onto this panel, and this panel works again. So thanks friends, and just keep in mind that I have brought a training for Kolkata peoples, only for people who works in this field, on 3, 4, 5 September of this year, and you have to get registered for that. For registration you can contact to me directly on my number 98258-42502, which I am just giving it in my description area also. Thank you friends.